Good morning. Last topic was we discussed up to temperature. I think we were discussing, right? Temperature, na? Factors. Did I discuss all the factors? Prevailing winds. I discussed about this winds, na? Complete it was. Okay. So in case of prevailing winds, what I said, tell me. Done. Now tell me, you have Atlas, all of you? Yes. Just find out page number 82. Go to page number 82. And on 82, just tell me, if I take this area that is nothing but our American part, let's say this is Gulf of Mexico here, and the second is here, the Gulf of California. Now tell me where the temperature would be more. Why? Because of? Because of? Just don't go by that one. Just give me the reason because of the winds. Hana? I just want to know why the winds are playing their role in the temperature distribution here. Just take winds alone. Now tell me where the onshore trade winds are and where the trade winds are offshore. Here, the winds are onshore. So onshore trade winds means they will increase the temperature or they will decrease the temperature. They will increase the temperature. So therefore, obviously, Gulf of Mexico will have slightly higher temperature. And what about this Gulf of California? The winds are coming from the land. They are dry. They are offshore. So the offshore winds will now drag the water from this area. Therefore, you will see the cold Californian current is reaching here, right? So what happens is, remember, this is how the winds are also playing their important role, right? So this is the factor of wind. Now, the second example, try to just write this example also in your notebook. Example, make this diagram. Gulf of California and Gulf of Mexico. So Gulf of Mexico will have more temperature than Gulf of California. Obviously, here you will write onshore trade winds. And here you will write offshore trade winds. There are plethora of the factors, but here primarily we are taking the winds only, the factors, right? I'm making this in red color so that you could differentiate. This is onshore. Now just open page number 76 and try to locate these two ocean bodies, North Sea and Labrador, just near the Sweden. Page number 76 it is, and just try to locate North Sea and Labrador Sea. North Sea on page number 76 you will find easily. Mila? Where is Labrador Sea? Near the Canada, Labrador Current. That is on page number 82, 76 and 82. Or if you want to locate them together, go to page number 106. 106. Page number 106. You can easily find near the Canada, this eastern side of the America, North America, Labrador Current is there. Yes or no? Yes. Then where is North Sea? You have located on page number 76. So the same way, where the temperature would be more? North Sea or the Labrador Sea? So North Sea, why? Because North Sea is under which winds? Onshore westerlies, right? In this way, you can easily differentiate. So example number 2, write down. The North Sea will have greater temperature than Labrador. Here the reason is onshore, but this time westerlies. This has been asked by the UPSC, so be prepared with this factor. It's important. How many factors we discuss? 3, 4. 3, fourth factor. If there is atmospheric stability on some particular region, what will happen to the temperature? Can I say atmospheric stability means no rainfall? If there is no rainfall means temperature would be slightly higher. So write down atmospheric stability means example near STHP belt, you will find temperature of the water will be higher. This is the fourth or fifth factor, whatever it is. Now this is again very important factor. Sixth or fifth it is, the next one. Fifth factor, enclosed and the open seas, right? Enclosed and open seas. This is very important for your prelims, right? See here carefully. So in general, you are now aware of this trend that if I go from equator to the polar area, the temperature should increase or decrease. It should decrease. Yes. So what happens is, I am just considering this is equator. Here we have the polar area. Now the in general trend is the temperature should decrease with this latitudes, from low to high. Now if I ask you, let's say we have, with this example you will be able to understand, otherwise it is difficult. Let's say we have two water bodies, one is A, the second is B. Obviously A has more volume of water. Now this is just, you can consider a bowl like of a structure. There are two bowl, one is A, one is B. Now we have the freeze here, that is refrigerator, and we have some, let's say the gas or something which is near the equator. Means equator is hot, and if you are going towards polar area, that is kind of freeze or the refrigerator. Now if I give you this two bowl, and if I ask you, if these two bowls are placed here in the tropical area, which bowl will experience high temperature quickly? A or B? B. So here B means, now see here, because it is difficult to otherwise explain this factor. B means it is enclosed or open. What I'm considering this one, it is more enclosed. Enclosed means it is surrounded by the land. And here I am considering this body of the water as more and less open, right? Now, if I just put these two plates in the lower latitude, now tell me, this is, I am taking here lower latitudes. In the lower latitudes, I'm just considering open water body or the enclosed water body will experience more temperature. Tell me. If I put these two plates here, if I put these two boats here on the equator, which will become more warmer? B or A? Obviously B, because it has less volume of water. So B, because B I am taking here, B is nothing but our enclosed, right? So the B will become warmer because of it is more and less enclosed. Okay? In our example, it is example figure B. Okay? Or here you can write down the temperature in B will be more than A. Yes, do you have the atlas? Just open page number, it should be 66. And just try to locate on this 66. Mediterranean. Is it visible on 66? Mediterranean? If not, then है दिख रहा है Mediterranean, and the second is Red Sea. Red Sea, both are visible. Mediterranean and Red Sea, more or less they are in the lower latitudes only. Yes, na? Yes, they are more or less in the same latitudes. Now tell me where the temperature would be more, in Red Sea or the Mediterranean, keeping only this factor in mind. Red Sea, why? Because it is more surrounded by the land. Yes. So the example that here we are talking about, it is the lower latitudes. And in this lower latitudes, the example is Red Sea will have more temperature than Mediterranean. See, they will give you this question in this form. They can ask you the Red Sea experiences more temperature than the Mediterranean. Why? Because of this factor, right? So you can write here in this manner, lower latitudes, at the lower latitudes, more enclosed water body will be warmer than the open water bodies. Okay? Then, second, now if I just want to put these two ports in some higher latitudes where the temperatures are very low. For example, if I want to keep them both A and B here, right? At this position. Now tell me where the temperature would be more, in A or B. This time I am just putting this two ice trays. These are ice trays, है ना? The ice trays I am keeping now in the refrigerator. Which one will become frozen completely? कौन सी? Smaller or the bigger one? Why? Freeze कौन होगा जल्दी? Bigger कैसे होगा? Only surface area you are considering, but volume of water is more, na? So volume of water will take time, okay? Because water will become warmer and cooler, and it will take time, okay? So if I put these two ports at the higher latitudes, which will have more temperature, A or B? Answer is A. Why? Because B will quickly indicate these temperatures which are low here. B is nothing but are enclosed. So in the higher latitude, please remember, in case of higher latitudes, the temperature in which body? The temperature in A would be more than B. So here I am writing. लैंड है ना, लैंड बहुत जल्दी क्या होगी, फ्री कहाँ पे टेम्परेचर बहुत जल्दी कम हो जाएगा, लैंड पे. सो इन द हायर लेटीट्यूड्स इन द नॉर्दर्न हेमिस्फीयर वी आर गोइंग, द लैंड पार्ट इज मोर, द लैंड इज वेरी वेरी कोल्ड, है ना? तो क्या होगा, जल्दी से ट्रांसफर हो जाएगा टेम्परेचर का. बे ऑफ बंगाल, बिकॉज इट इज सराउंडेड ना, इट विल हैव मोर टेम्परेचर देन अरेबिक कंपेरेटिवली, बिकॉज इट इज थ्री साइड एनक्लोज. लैंड के कांटेक्ट में, इफ द ओशनिक वाटर इज मोर इन कांटेक्ट विद द लैंड, then land will transfer its energy to the oceanic water. So remember this factor, right? Now just go to page number 76 and try to locate these two water bodies. This time it is North Sea and Baltic Sea. बताइए कहाँ पे टेम्परेचर ज्यादा होगा? North Sea and Baltic, which is more open? North Sea, yes. Now see here, in the higher latitudes we are now, yes or no? Yes, in the higher latitude, one you have the North Sea, that is comparatively open. The second you have Baltic. Baltic is more or less enclosed. So where the temperature would be higher, it is in the North Sea. So the second example here, open sea, you can write here. Therefore, in the North Sea, temperature would be more than Baltic. This is important for your prelims, Sarah. Done? Done? So factors we are done with almost. Next is horizontal distribution of temperature. Horizontal distribution means if I go from the latitude equator towards the polar area, what should be the temperature? So in general, we have learned this one already. So from equator to the polar area, in general, temperature decreases from equator from lower latitudes to higher latitudes. Except you are now aware of this factor, except STHP area. Here the temperature will increase again, right? Otherwise, this is the general trend. Yes? Can I say the horizontal distribution of this oceanic water temperature can also be understood with the help of isotherms? Yes or no? Yes, isotherm means what was that isotherm? What is the definition of isotherm? What were they? These were the imaginary lines, na? These were the imaginary lines connecting the same temperature points. What was the disadvantage of the isotherm? If I am a farmer, what was the disadvantage of this isotherm for me? Yes, so they are not the indication of actual temperature. Rather, the temperature has been taken by keeping this area at the sea level. Okay? So now here horizontal distribution, write down horizontal distribution of temperature can be understood with the help of isotherms. Okay? So this is in general the trend in horizontal distribution of temperature. The important one is this one. Vertical distribution of temperature. This is important for you. See, on x-axis, I am taking here the temperature. See here, this is the temperature. Let's say this is 27, 25. In this way, it is reducing here. And I'm taking 0 degree C, somewhere 2 degree C here. So temperature, if I want to write, the temperature is maximum here. Maximum. And the minimum temperature is here. So we have divided this ocean into three areas. One is the 200, top 200 meter. The second is 200 to 1000 and beyond 1000, right? This is beyond 1000. Now, why this 200 meter? Because this is the zone which I can write here. It is nothing but photic zone in which light can penetrate. Which light? Sunlight can penetrate up to here. So, because I can say easily the sunlight is penetrating here in this layer, can I say the temperature in this layer would be slightly higher? Yes or no? Yes. So, if I go by the general trend of this vertical distribution, on the surface you will experience somewhat around 26, 27 maximum I'm taking here. Otherwise, this should be taken 25. So, somewhat I'm starting here, okay, in between. So, the temperature will remain more or less same in this 200 meter. Why? Because the sunlight is distributed. Now after then, see here carefully, see here. After then what happens is this temperature will register a very sharp decline. Okay? So what happens is now the temperature will decline very quickly and it will reach up to here. And now onwards the temperature would be more or less near 0 degrees C. Yes. So why the temperature is declining at a very faster rate in this zone? Because in the bottom we have the cold denser water which is separated by this layer that is 2000 to 1000 by the upper layer. Why upper layer has the more temperature? Because of sunlight is penetrating here. And why this area has registered or this area is registering very fast decline? Because it is now you can consider this is let's say up to 300 meter. Sunlight penetration has been stopped now. And now onwards the temperature will go down very quickly. Right? So just write here some of the things. This zone in between 200 to 1000, this is known as thermocline. Thermocline. Thermocline means? Cline means it is gradient and thermo means temperature. It means the temperature is changing quickly. I'm not using the term decreasing or increasing. I am just saying it is the steep change in the temperature, right? So right here, thermocline. So we have three layers. One, the upper one, the second, this thermocline, and the third is the bottom one, right? Hanji. Thermocline. LL, this is. Thermocline. Thermocline means temperature is changing very rapidly here in this zone, thermocline. Okay, in some of the books, this can also be taken as 200 to 500 meter as well. Okay, but 1000 is safer. Done? So we can divide this vertical distribution, and remember, this is I am talking about only tropical and subtropical areas, right? So only we are talking about which areas? This line is for tropical and subtropical area. Now see here. This is we are talking about tropics and subtropics. Now, why in the subtropics and subtropics? Because on the tropics and subtropical area, you will have more sunlight. So this is the line for the tropical and subtropical areas. This line will exist for the mid latitudes also, but only in case of summers. Okay? And now, what about polar areas? So, polar areas will register more or less the same temperature. Okay? From top to the bottom, more or less same would be the temperature. This is for the polar areas. Right? This is your polar areas. Now, can I say safely for the polar areas, thermocline is absent? Yes or no? So, write down. Layer of thermocline or thermocline zone is not found in polar regions. And here one more, just write down for the temperate regions, this type of the graph will be followed, but only in case of summers. So write down. Right? Please remember for the temperate or mid latitudes, the same thermocline will be found only in which season? Summers. Okay? So please remember this distribution. It is important for your prelims as well as for the mains also. Then, now very simple question I'm asking. This is all the story of the temperature. We are finished with the temperature. The question from the temperature in the prelims, you can obviously get from the factors and from the distribution of the temperature. Obvious questions will come from this area. In the mains, they can ask you what are the factors which can influence the temperature of the oceanic water and how they are important for the general regulation. This could be the question, right? We'll understand what is the general circulation or the regulation of water. Now the question in the mains, then it can be, in the prelims, if I give you this statement, the change in temperature, vertical change in the temperature in the equatorial areas would be more faster than the change in the vertical temperature in the polar area. Tell me, is it correct? Yes, yes. Can you see this one? The rate of temperature change here on the surface in the tropical area, it was 25, and at 1000 it is near zero, whereas in case of polar area from surface onwards it was more or less zero only, right? So the temperature is not changing quickly here, rather temperature is changing under the equatorial water. So this one more statement please write down here in a diagrammatic manner. This could be another prelims statement. They can ask you where, under which waters the temperature changes very rapidly. It is equatorial waters, right? Or the tropical waters, rather. Yes, salinity now, or before salinity, density rather, density. Density of oceanic water. Density of oceanic water. On an average, this is going to be the density not required at all. I'm just giving you one figure. 1.0278 is the density, gram per centimeter cube. It is the unit, right? So what is density of the oceanic water? Simply how closer these molecules of the water they are, then the density will be determined. Now, why the density is important? Because it is the density which will decide which waters will float and which waters will sink down. Now tell me, if I ask you, if it is the denser water, it will float or it will sink? Yes, so write down the density will decides the floating and sinking of oceanic water. Denser water sinks down and less denser water will float, right? Can I say therefore the movement of the oceanic water also is having some control of the density? Yes, na? So can I say here, therefore, density of water plays vital role in circulation of oceanic water. In circulation of oceanic water. I discuss western disturbances somewhere. कहीं discuss किए मैंने western disturbances. Yes? Huh? I just mentioned them. Did I talk about their trend which is changing now? No? Did I discuss that? There I mentioned some amok cycle somewhere. No? ठीक है. Now less denser water will float and now the density will be affected by some factors. And these factors are, number one, greatly it will be affected by the temperature of the water. Now tell me, what could be the relation between temperature and density? If the temperature of the water is increasing, what will happen to the water? It will expand or it will contract? It will expand. If the water is expanding, what will happen to the density then? Density will decrease or increase? Density will decrease. So simply the temperature, if increases, so it is inverse relation in between temperature and density therefore. Yes? Therefore, this relation is inverse. Now, if I say, if I am decreasing the temperature, what will happen to the density? Density will increase or decrease? If I am decreasing this temperature, the density will increase. Obviously, if you will freeze the ice, or if you will freeze the water, sorry, so what will happen? The density of the ice is more or the density of water is more? Density of ice? Yes or no? Ice will float, na? Or sink? डेंसिटी 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 किसकी ज्यादा होगी, आइस की कि वाटर की? अरे वाटर की डेंसिटी कब से ज्यादा हो गई यार? आइस की डेंसिटी विल बी ग्रेटर. व्हाई? बिकॉज द मॉलिक्यूल्स आर कमिंग क्लोजर टू ईच अदर and therefore ice will sink or float? Ice will sink or ice will float? That will be determined by many of the things, right? Especially the surface area and the volume of the water which is displaced by the ice. Otherwise, ice is heavier and denser. समझ में आया? Now what happens is, if I am decreasing this temperature, obviously it is resulting into density is increasing. Yes? Now, what it is the meaning? The meaning is the water molecules are coming closer to each other. Now, see here, I am just giving you two waters. One is at, let's say, 20 degrees C, and the molecules are placed in this manner. Okay? Now, the second water is I'm giving you at, let's say, 4 degrees C, and the molecules of the water are coming closer to each other. The third water is at 0 degrees C, and this is your ice, है ना? The density is maximum 0 degrees C. Yes. Now, can I say it is the temperature which is controlling the density primarily? Yes or no? Yes. But in this picture, there is one problem. The problem is water has the control over this density up to 4 degrees C only. After then, this density will not be controlled by the temperature. Why? ऐसा ही रहेगा. This would be the density pattern. Why the temperature loses its control on the density of the water beyond or less than 4 degrees C? अब वहां से कंट्रोल कम हो जाएगा. Up to 4 degrees C, the great control will be exercised by the temperature. But less than 4 degrees C, the control of the temperature will be very, very less. Why? I am saying, huh? What I am saying is the density here and the density here. Okay? Let's say the density is here. I am assuming this is 1.028. Now I am saying there would be a very less effect of the temperature. If I am reducing this at 0 degrees C also, it will remain more or less 0.28 only. My question is why temperature is losing its control now onwards after or less than 4 degrees C. Let's say this is 4 degrees C, and beyond this 4 degrees C, density will remain more or less this one. ऐसा क्यों? Because what happens is the molecules are already now very compacted. So इससे नीचे कितना ही temperature कर लो, there is no space left. ठीक है? The water is at its peak density. समझ में आया? So the temperature exercises the great control, but up to 4 degrees C. ठीक है? इसके बाद the temperature will lose the control. Right? So right here some of the things. Temperature exercises great control. ठीक है? So beyond less than 4 degrees C, now onwards the temperature will have very less effect on the density. ठीक है? It will have, but the major control was exercised up to here. ठीक है? So now onwards the temperature will not be the main factor behind the density. ठीक है? Because the molecules are already at a minimum distance from each other. Already they are highly compacted. This is the factor. Now, if I understand, this is the great control on the density was exercised by the temperature. If you have the temperature graph, can you give me the density graph then? We have just now learned the density. We have just now learned the graph of this temperature distribution, vertical distribution. Can you draw the density distribution, vertical graph? Can you? Yes? अरे अभी देखा ना, we just have learned this graph. This was the graph, है ना? Here the temperature was somewhat around 25 degrees C, and we have learned write down the density and temperature curve or the distribution of density. Temperature was maximum here, yes or no? Yes, let's say 25 I am assuming here. It was thermocline. Now tell me, what is the relation in between density and the temperature? If the temperature is maximum here, density would be least or maximum? Density would be least, yes or no? Yes, so density is minimum here. And density would be maximum here. So the graph would be same, yes or no? Yes, this would be the graph, but you will read this readings in this manner. Density is minimum, density is increasing, and here the density is maximum. The graph would be same exactly, but the only thing is I have replaced this word maximum here minimum and maximum minimum, right? So this is the change. Now, can I say if the temperature was decreasing, or let's say the temperature was changing very quickly here, and the so would be reflected in the density, yes or no? Yes or no? Yes. If the density was minimum here up to 200 meter, now what will happen to the density now? Density will quickly change. Yes or no? Yes. And what happens is the density will reach maximum in this area, right? So make this graph. Can I say the density will register the same? The same layer in which the density will change very quickly, this is also the layer in which density will changing, temperature and density both are changing very quickly. For the density, this will be known as pycnocline. Pycnocline. Pycnocline means layer in which density of the water changes very quickly. Can I say this is nothing but the line of again for the tropics and subtropics, yes or no? For the tropical and subtropical area, this would be the line. Pycnocline. Pycno means it is about density. Yes. Now here, just see this another graph. The another graph was, we have already learned, this was in the polar area. Yes or no? Yes. Now, can I say the same would be applicable in the polar area? Means, can I say pycnocline will also be absent here in the polar area? Yes or no? Yes. Because here the density will be more or less same. So write down pycnocline, both thermocline and pycnocline remain absent in the polar area. Then this is density and temperature, relation of density and temperature. So the relation is there in between salinity also, salinity and density. So the second factor, are we done up to here? Yes. Second factor, density is controlled by second factor, and the second factor is density is controlled by salinity. Now tell me, what is the relation between salinity and density? If you have fresh water and if I'm adding some of the salt in that one, what will happen to the density of the water? It will become thicker, or it will become, let's say, liquid, more liquid or fluid. It will become thicker, yes or no? Yes. Can I say the density of the water molecules is increasing or decreasing? The density has the direct relation with the salinity. So write down salinity is in direct proportion to the density. Density increases with the salinity. Okay, we'll see this relation in detail, don't worry. The third, it is pressure. Minute factor it is. Now see here, pressure. Now we already have learned the highest density water is found in the bottom. Why? Why the density is maximum? Why the density in the Earth's core was maximum? Why? Because of superincumbent load, one factor. The second was nature of the minerals itself. Now, if I consider the superincumbent load of the entire this area, can I say therefore, due to this pressure which is being exercised in the bottom layers, this density would be maximum in the bottom? Yes or no? Yes, because of the superincumbent load. Remember, this is only a minute factor. It's not the one which is greatly controlling the density. Density is controlled greatly by this two factor. One, temperature, second, salinity. This is only minute factor. So write down in this manner. That is only a minute factor. Please remember this one. That so this is the story of density. Okay? And the prelims, if you are asked the question, remember these are the three factors which are controlling the density distribution, right? One more relation we will understand of this salinity and density, but first I'll discuss this salinity, right? So write down the third factor, that is salinity. Salinity of the oceanic water. What is the meaning of salinity? It means simply we are saying how many molecules or the particles of the salt are there in 1000 ml of the water, right? So write down very simple language in the salt in grams in 1000 grams of seawater. Salt in gram and 1000 gram of water. Now in this, just tell me, if I say gram divided by 100, can I say this is nothing but gram percentage? Yes or no? Yes. If I take this is 1000 here, so therefore it is written in this manner, 00 it would be. Okay, in the bottom. So salinity is represented by PPT. Write down, salinity is represented by PPT. PPT means parts per thousand. Means how many parts in gram are there in 1000 parts of oceanic water. So write down. PPT, and this is the symbol. Okay. On an average, the salinity remains around 35 in the oceans, right? Means 35 means somewhat 35 parts would be found in 1000 parts of the oceanic water. This would be on an average, right? However, in some of the water bodies, it can go as high as 38, 39 also. Okay, for example, we have the dead lake of the, kahan pe hai dead lake? Dead Sea कहाँ पे है? In the Israel region. Yes. So the salinity is very high in that area. Lake Van in the Turkey. It is also having the high density, right? Now, in this salinity, just write down based on the salinity, write down the next line. Based on the salinity, water bodies can be divided into following. Freshwater bodies, brackish water bodies, saline water bodies, and brine water bodies. Freshwater body, brackish water body, saline and brine. If the salinity is in between 0 to 5, then it is fresh. 5 to 35, brackish. 35 to 50, saline. More than 50, brine. Right? Fresh water, brackish water, saline, and brine. Now, based on this fresh water, means based on the salinity content, fresh water, can I say the rivers, lakes are the example of fresh water? Yes. So here we will divide this into two parts. One is I will call as lotic system. Lotic system, and second is known as lentic system. What is lotic and what is lentic ecosystem? You will come to know in case of your environment. Lotic means moving water bodies. For example, can I say rivers? What is lentic? Lentic means stagnant water bodies. And here example is lakes. O stands for moving. Right? Lotic ecosystem. Lotic systems means moving water bodies. Lentic system means lakes. Stagnant. All the moving rivers, more or less the example of freshwater lake, freshwater system. And some of the lakes, write down the example of freshwater lake, Wooler Lake. Where it is situated? Yes, write down Wooler Lake. Second, Loktak Lake. Where it is? It is Manipur. Freshwater lake of Manipur. Loktak Lake. Dal. Dal also, it is situated in Jammu. And one more, it is Koleru. Koleru. कहाँ पे Koleru? It is Andhra. ठीक है, just open page number 10. Try to locate Koleru Lake. It's in the border area of this one, Andhra. Koleru. Can you find this Koleru? It is in the Andhra. ठीक है? Brackish. Write down examples under brackish water. We have written 4 examples. Dal Lake, Wooler Lake, both are in Jammu. Then Loktak Lake, Manipur. Then the Koleru, Andhra Pradesh, right? Then examples under brackish system. Number 1, Chilika. Where it is? It is in Odisha. Open page number 10. Try to locate Chilika also. If not mentioned here, then go to page number 23 or 22. है यहाँ पे? Yes. Page number 10. See the page number 10 and try to locate Chilika. Can you find Pulicat, Andhra Pradesh and Tamil Nadu border in between these two? Pulicat Lake. Andhra and Tamil Nadu. Pulicat. If not mentioned here, go to separately the page number. It is कहाँ है? 24. 24. Pulicat Lake. Pulicat is shared between Andhra and Tamil Nadu. 2% in Andhra, 98% in Tamil Nadu it is. दिख रहा है map में? Is it visible in the map? Most of its portion lies in Tamil Nadu. Oh, sorry, Andhra. है ना? Most of its portion lies in Andhra, sorry. दिख रहा है? Is it mentioned? Pulicat Lake, Dikhi? Chilika? Then come to Kerala on the same page. Vembanad. Can you see Vembanad Lake? Vembanad dikh raha hai? Kerala. In the bottom. Vembanad. Yes. Bottom to the Vembanad, Asthamudi. In the Kerala only, Asthamudi. Yes. So these all are the example of brackish water lakes. Brackish water. It is Asthamudi. Vembanad. Both are in Kerala. The largest lagoon water body of the Kerala, Vembanad, Asthamudi. Then we have learned about Chilika. Then Pulicat. Right? All they are the example of brackish system. Means salinity is in between 5 to 35. Then saline water. All the oceans are the example of saline water system. Then brackish, write down. Brackish example, Sambar Lake. Brackish, brine. The last, fourth one, brine. Number 1, Sambar Lake. Where it is? It is in Rajasthan. Then second, Dead Sea. Israel. Dead Sea. Then Van Golu. Turkey. They are the example of brine system. Brine means the salinity is more than 50, right? And therefore what happens is even the human being can float easily in this water bodies because of high density of the water. ठीक है, आराम से आप तैर सकते हो, but जाना मत. Next, now my question is, how come this salinity is there in the oceanic water? कहाँ से आती है salinity? What is the source of salinity of the oceanic water? What is the source? Rivers. They themselves are the example of fresh water body. Then why they are not itself? Evaporation. What evaporation? क्या? बोलो कुछ. In oceans or in rivers? कहाँ पे evaporation ज़्यादा है? Evaporation. What is the source of salinity for the oceans? Tell me. Minerals. From where these minerals are reaching into the ocean water? Huh? Seabed, okay, but majorly it is contributed by the rivers from the continents, yes? So the sources of salinity are obviously number 1, sediments, mineral sediments brought by rivers. And also in the oceanic bottom they are found. Then second source is underwater volcanic activity. How the volcanic activity will contribute to these salt particles? Because rock is nothing but, for example, there is any MgCl rock. If it is coming out with the volcanic activity, it will contribute salt, yes or no? Yes. So the volcanic activity, these are the major source. Now the largest source of the salinity is the rivers, right? Now my question is, if the river are the major source of the salinity, then why rivers themselves are considered as the fresh water bodies? This is my question, tell me. Will not waste time here, see here. So rivers will have the calcium more in these waters, right? So calcium, what is the taste of calcium? In our milk, it is the calcium which is found. Na? What is the taste which is given by the calcium? It is somewhat sweet taste. Hai na? So if the rivers have the calcium in dominance compared to the Mg and Na, what happens is they are comparatively freshwater resources, right? Now what happens is when the river jumps into the ocean, in the ocean there are some of the processes which are going on. Number one, the carbonation process. Carbonation means the calcium will be utilized with the CO3 and calcium carbonate rocks will be formed. Number one. Second, there are so many organisms which are forming their shell. Yes, for example, corals, they are making their own body and that is made up of what? They are also made up of calcium carbonate. So this calcium will be used in great amount in the oceanic water by the organisms of the ocean. Also, it is going to be deposited in the form of carbonate rocks in the ocean. So what happens is overall the concentration of calcium decreases in the ocean. अगर ocean में calcium कम हो गया, so what we are left with now? Mg and Na. So if Mg and Na are increasing, it means the salinity will increase in the oceanic water. Can you understand now? Yes. So because of calcium which is found in dominance in the rivers, they are not considered as the saline water bodies. Done? So this is the major source of the salinity for the oceanic water, the rivers and their sediments. Now again we will learn. समझ में आया यहाँ तक? Yes. Next, we will also learn about salinity in three ways. Number one, the factors, the same. Then second, both horizontal and vertical distribution. So first is factors. Factors affecting salinity, the first one. Number one, write down the factors. Number one, addition of fresh water. Now tell me where the major rivers of the India are draining. Can I say they are mostly going into which side? Bay of Bengal, yes or no? Yes. Now tell me where the salinity of the water will be higher in case of Indian Ocean, Bay of Bengal or Arabian? Arabian, yes. Why? Because of the fresh water addition right down here. The first relation is, in case of Arabian and Bay of Bengal, we have the high salinity in the Arabic side. If you go to page number 66, go there and try to locate these two rivers. One is Euphrates, one is Tigris. Page number 66 in the area of this one, Iran. Try to locate these two rivers. One is Tigris and second is Euphrates. Al-Bashra is the point at which they two are meeting, and then they are going into Persian Gulf or Red Sea. Just try to locate Persian Gulf. आपको मिल जाएंगी these two rivers. Can you find Persian Gulf? Page number 66, Persian Gulf. These two rivers are draining into Persian Gulf or Red Sea? They are draining into, कहाँ पे drain कर रही हैं? Red Sea or Persian Gulf? Tigris and Euphrates, they too are entering into Persian Gulf, not Red Sea. Persian Gulf दिखा? On page number 66 it is not mentioned. अरे यार, एशिया में होगा. अरे यार ये रही ना दोनों, देखो ना, Tigris and Euphrates, right? They two are here and they are draining into the Persian Gulf. This is Gulf written, it is Persian Gulf actually. This is Tigris and here it is Euphrates. They both are meeting at Al-Bashra is the point and then they are draining into Persian Gulf. Right? This is the area where this Mesopotamia civilization was located. Earlier, all the civilizations were near the river or the water bodies, na? So in between these two rivers, it is your Mesopotamian civilization. यहाँ पे थी, ठीक है? So here it is your Persian Gulf. Now tell me, we have two water bodies there itself. One is Red Sea, one is Persian Gulf. What do you think? Where the salinity would be more? Persian or Red Sea? Yes, because of the addition of water in the Persian Gulf, the salinity will be lesser in the Persian Gulf compared to the Red Sea. So write down. Second example, Persian Gulf will have less salinity than Red Sea because of the rivers which are being added here. Go to page number 76. There is Mediterranean and then the second is Black Sea. Can you find all the rivers which are starting with the name D? For example, Dniester, Dnieper, है ना? Then Danube. Can you locate them? Volga. They all are draining into Black Sea or the Mediterranean? Tell me. They all are going into page number 76. देखो ध्यान से. Volga is going into Black Sea or the Caspian? ध्यान से देखो. This Volga is going into Caspian or Black? Volga is going into Caspian. Tell me the names of the rivers which are going into Black Sea. Can I say this? Dniester, Dnieper, Danube, Don? One more. Don, can you see? Don is also there. है क्या? Don है? So all these D names, Don, Dnieper, Danube, Dniester, they all are going into which body? Black Sea. ध्यान से देखो वहां पे. And because of that reason, Black Sea will have less salinity compared to Mediterranean. So Black Sea will have because of this reason. Fresh water is being added in the Black Sea more compared to the Mediterranean. Done? Next factor, rainfall. Second factor, rainfall. Tell me, if the rainfall is higher in some area, what will be the salinity then? Salinity will reduce or increase? It will reduce, right? So write down salinity. Again, it is nothing but again addition of Can you tell me one very basic question? Why in the rainfall water is fresh water, not the saline, even if the evaporation had occurred over the water bodies? Yes, very good. Saline or the, let's say, the salt content will remain with the ocean itself. The only evaporation will come up with the fresh water. Okay? So now addition of the fresh water will reduce salinity. Here it is our Red Sea. Bay of Bengal is this one. We have Arabian here, and Persian Gulf is here. Now tell me where the salinity was highest, Red Sea or the Persian? In between these two, Red Sea or Persian? Red Sea. Then it was Persian. Then compared to this Arabian and Bay of Bengal, Arabian was having more salinity, then Bay of Bengal was having less. Now tell me, if I consider this is our Andaman and Nicobar, it is, can I say, near to the tropics? Yes or no? Near to the equator? Yes or no? Yes. So equator type of the climate may or not may is found in this Andaman and Nicobar. Yes or no? Yes, especially in the Nicobar group, it is because closer to the equatorial region. It is in the equatorial region. So daily rainfall is also the phenomena in the Andaman Sea as well. So if I say in the Andaman, what would be the salinity therefore? Andaman Sea. It would be least, yes or no, because daily rainfall is the phenomena here. So Andaman Sea will have the least salinity because of the addition of fresh water by daily rainfall, right? So write down here. Now see here the pattern for your prelims. See here the pattern is salinity is decreasing or increasing. In this way, salinity is decreasing. The Andaman will have the least salinity and the Red Sea will have maximum salinity. For your prelims, please remember. Okay? So out of these three water bodies in the Indian Ocean, Arabic, Bay of Bengal and Andaman, where the least salinity is found in the Andaman water, right? So Andaman Sea. Salinity is least here compared to these two water bodies. Salinity is minimum here in the Andaman. Please remember this one. Third factor. Page number 76 and locate these two water bodies. One is Gulf of Bothnia, second is Baltic Sea. Which water body is more closer to the ice caps and glaciers? Gulf of Bothnia. Now tell me where the salinity would be least. कहाँ पे होगी? Out of these two water bodies, the salinity will be more in Baltic. Here in the Gulf of Bothnia, the salinity is only 5 parts per thousand. Okay, because of the fresh water which is being added by the melting of glaciers. Can I write this factor as high latitude water bodies will have less salinity due to fresh water addition by melting of glaciers. So far, we have learned these three regions in the salinity, and all these three regions were responsible for reducing the salinity. Yes, addition of fresh water, addition by the rainfall, addition by the glaciers. Now, the another factors 4, 5, 6 onwards, they all will increase the salinity, right? For example, write down the fourth factor is evaporation. So rate of evaporation, if it is higher, then salinity of the water body will increase. Yes. If I ask you a question, even if the Mediterranean Sea, which is larger, है ना, in volume compared to the black, still it register high salinity. Why? My question is, the Mediterranean is larger in case of volume of water. ठीक है? Still its salinity is higher than the Black Sea water salinity. Why? Because of less addition of fresh water compared to the Black Sea. Okay? Fresh water is being added continuously by the rivers in the Black Sea. Fourth factor, evaporation will be responsible for more amount of salinity, right? The fifth factor, presence of currents, that is warm or cold. I am taking again the same example. Gulf of Mexico and Gulf of California. Now tell me where the temperature of the water was more. Gulf Stream. This is the Gulf Stream. So Gulf Stream is warm. Go to page number 106. You will find this one is mentioned in red color. And here this is your cold current of California, right? The warm current and the cold current. We have already learned that the water in the Gulf of Mexico will have higher temperature than the water in the Gulf of Mexico. If temperature is high in this area, what would be the rate of evaporation? It would be high. So what happens to the salinity then? Salinity will also increase. So in this area, therefore, you will find the salinity would be 37 and here it is 34. Okay, so remember this one also. Can I associate this region with the winds also? Winds के साथ associate कर सकते हैं? Can I associate this factor with the winds also? What was the reason behind this warming effect? It is the onshore trade winds, yes or no? Offshore trade winds, yes. The next factor would be the wind pattern. Here, just write down one example is this one. Can I say the another example that you can see here? This is also you can write here about North Atlantic drift. North Atlantic drift. Can I say the North Atlantic drift will increase somewhat salinity in which area? Somewhat salinity will increase near the Europe. And which part of the Europe? Western part of the Europe, right? In this way. So presence of the current, if they are warm, salinity will increase. If they are cold, salinity will be somewhat lesser. Okay? Presence of the currents. Then, next factor, prevailing winds. Can again associate this with the same. Prevailing winds. Okay? Here we have already learned prevailing winds will also increase salinity in some of the areas. Yes. Why? Because of they have direct bearing on the temperature distribution. So here itself I am connecting here. The trade winds were responsible for what? For bringing this warm current here. Right? So the winds which are here. So I'm writing here. Offshore or onshore? Onshore trade winds. Bring warm water in the western parts of ocean. I am writing western parts of ocean. Therefore, salinity increases in such areas, that is in the western parts of the oceans. Okay? This is the distribution of salinity. Please remember the water bodies, especially which I have given you in the example. These are the example which are standard in which the UPSC may enter. They will ask you what could be the patterns of salinity, what could be the patterns of temperature, right? So these are the factors which in general are controlling the salinity, right? Next is horizontal distribution of salinity now. Salinity should increase or decrease if you will go from equator to pole in general. In general, it should decrease or increase? It should decrease, yes. So what happens is, in general, I'm writing here, salinity decreases from lower latitudes to high latitudes. What is the exception? Exception is STHP. Hanji. Why? Decreases, na? Lower latitudes will have high temperatures. Okay? We are talking about surfacial water only, not the vertical distribution. On the surfaces, if the temperature is high, what will happen? Evaporation rate would be more. Evaporation rate is more means the salinity concentration would be more in the upper layers. We are talking only about the upper layer. Okay? Upper layers. And when you go towards the, let's say, polar areas, what will happen? Number one, insolation will reduce. So insolation, if it is less, temperature will reduce. Temperature, if it is less, salinity will slightly increase. Okay? In the polar area, there is no insolation. More or less, there is only glaciers. So the fresh water would be there. See here, in case of salinity, there are very high complexities are associated. There are so many things which are controlling salinity. I have written here in general, therefore. So what happens is, in general, we are considering only the factor is temperature and insolation now. Or rest of the factors we are keeping at the back seat, right? So in general, what happens is, this is the trend, except STHP. So if it is the horizontal distribution which has been asked, please remember you will have to mention this word also, because otherwise there is so many variations in the salinity distribution. It will depend kahan pe exactly how much of the water is being added. If the less water is added, salinity will change in this way. Okay? So there are so many factors. You will have to write this word very clearly. Now in the equatorial region, I'm mentioning here, let's say this is STHP. Why the STHP will have the maximum salinity? Tell me. Because of there is no rainfall at all. Yes or no? Rainfall is not there. Atmospheric stability. You can also add one more factor, that is atmospheric stability. That is nothing but related to rainfall directly. Okay? Atmospheric stability. And next is highest temperature would be found here. Highest temperature will be responsible for evaporation. Oh, sorry. In which hemisphere salinity would be more, southern or the northern? Tell me. Think carefully, then batana. In which hemisphere salinity of the oceans should be slightly higher than the other oceans in the other hemisphere? Kahan pe salinity is greatly contributed by the rivers. If the river water is being added, okay, fresh water is being added, then salinity will slightly decrease. Kahan pe ज़्यादा होगा? In northern hemisphere. So write down somewhere in the side. Right? So remember this one. Slightly the salinity is higher, and this slight difference is only this much. Average 34, 35. That's it. Right? So horizontal distribution, please remember, in the equatorial region, it would be somewhat around 35. In this region, STHP, this would be somewhat around 36 to 37. Why 35 in the equatorial area? Because of the rainfall addition, because of heavy rainfall, right? So please make a diagram here itself and write this all the factors. Again, making a clean diagram. 35 it is. Because of rainfall, some salinity will be lesser somewhat here. STHP, we have learned the regions 36 to 37 here. Okay, then again it will reduce now continuously, then salinity will reduce. This is horizontal pattern. Please remember, if you are asked that what is the horizontal distribution of salinity, and what are the factors which governs the horizontal distribution. Then you will have to mention all the factors and then just talk about general distribution in this manner. Next, there are in the salinity, in the horizontal distribution only, there are spatial and temporal variations in the salinity distribution. In the salinity distribution, temporal and spatial distribution or the variations are found in the distribution of water. What is spatial? It is related to space, right? Or location, right? The second is temporal, means it is related to time. Now, based on time, tell me in the summers and in the winters, what will happen? Keeping all the factors aside, all the factors are, we are now keeping them aside. Only thing is the water body which was having, let's say this was the water body earlier, it has the salinity of 34. Now, if it is the summer, what will happen? It will increase or decrease? It will increase. So this is temporal variation based on the season. Salinity will be with insolation. And here winter, slightly salinity will reduce. Location means, for example, in the locations, let's say this is the ocean, entire ocean, and here one river is draining into the ocean. This is the river. Now, if I talk about this area, in this area, salinity would be more compared to the rest of the ocean, or salinity would be lesser compared to rest of the ocean. It would be lesser. So can I say near the deltas, near the estuaries, less would be the salinity of the oceanic water? Yes or no? Yes. So high salinity here. This is your ocean. Here it is the river. And here it is, let's say, the delta or the estuarine area. So these are space related, means location based variation. If it is the location of delta and estuaries, there would be less salinity. If otherwise it is the general location, the salinity will be higher. So there are some variations also based on temporal and the spatial. We can say that salinity will be impacted. जी बहुत कम होती है, 33 के आसपास, around 33. Around the poles, what you are asking, salinity, it would be somewhere around 32 के आसपास, 32, 33. ठीक है? हाँ. Salinity will, नहीं वहाँ पे अलग है, मैं अभी बताऊंगा. Vertical distribution will explain. Just now I am going to explain that vertical distribution. Don't worry about that. ठीक है? Yes. There are so many variations. In general, you will find less is the salinity towards that side, polar side. है ना? Depending on the size, depending on the ice, depending on the glacier melting, the salinity could be as low as 5 also. We have seen in Gulf of Bothnia. Okay? So, in general, we can say. Otherwise, there are so many factors which are controlling. Then, in some of the cases, it would be less than 5 also. Gulf of Bothnia, then Arctic में जाओगे और कम हो जाएगी. ठीक है? So, there are so many variations. Remember one thing, in the salinity, they will ask you general pattern, because there are so many things which will work simultaneously and govern the pattern of salinity distribution. So they will ask you the question in general. Okay? And if it is not mentioned in general, you will have to consider they are asking in general what should be the pattern of distribution. Right? In general, ही आपको बताना है. Next is, we are done with the horizontal distribution. Now, vertical distribution of salinity. There is no definite pattern in case of salinity distribution vertically up to down. There is no fixed pattern, right? There is no fixed pattern in case of salinity distribution, but some of the points you can write here. Some points just I'm giving you. Write down point number one. At the equatorial areas, low salinity is found on the surface. Low salinity is found on the surface due to high rainfall. Low salinity is found on the surface due to high rainfall compared to the tropical areas, compared to the tropical waters, compared to the tropical waters. Okay, on the surface we are talking about. Because of the high amount of rainfall. Okay. Next, in the polar areas, salinity increases with depth. Salinity increases with depth. Why? Salinity increases with the depth. Now say here, I'm just making this diagram. Do not make as of now. Just understand first. Now say here, in the polar area, this is polar area. And here, what you are saying, on the surface, salinity is less. है ना? Salinity is somewhat less compared to the bottom. Why? Why on the surface, salinity is less compared to the bottom? Because fresh water is being added on the surface. So therefore, slight change would be there in the salinity. So on the surface here, you will find the salinity somewhat 31 to 32. Here I am taking in the middle, let's say 33. So if you are going down, the salinity is increasing. But don't worry, this is not the fast or the steep change. From 31, 32, somewhere you are reaching in the bottom 33. So the slight change is registered in the vertical distribution of the salinity, and hence density also, can I say? Density of the water will also increase in the same manner? Yes or no? Salinity has the direct relation with the density, yes or no? Yes. Can I say if you will go into the bottom, which area I'm talking about? I'm talking about which area? It is your polar areas. So please remember here, in the polar area, salinity on the surface, I'm writing with me, write down this one. Yes, right? Now the fresh water is being added here. Now can I say if the fresh water is being added here, the salinity would be lesser here. Rather than now, what will happen? If you will go down, the salinity and density both will? Salinity will increase. And here in the bottom, salinity would be somewhat 33, around 33. Okay, this is the pattern in the polar areas. Remember this one. So I am writing here salinity will increase. This is the second zone onwards. The salinity will increase and then it will come around 33 here. So this is not a major change. Please understand this very carefully. Just we have added fresh water, the salinity will be somewhat lesser. Now, if you are going down, salinity is increasing. Why? Because fresh water addition was limited on only in the superficial areas. समझ में आया? अगर नहीं आया, this question is never gonna be asked. Why? Because vertical distribution is not a thing which is controlled by one or two factors. There are so many factors. Remember this one. Therefore, I clearly mentioned there is no definite pattern. So we are drawing this in general patterns. What are in general patterns? Which are, let's say there are 100 water bodies. In 60s, you will find this type of the pattern. So therefore, we have drawn a conclusion. This is general pattern. समझ में आया? Otherwise, there are so many factors which are controlling this water and the density. Remember this one. And now why, when we are reaching to the bottom, why the salinity is higher here? Because in the bottom, the water which is found in the bottom, it is densest or it has less density? It is the densest water, na? So if the density is more in the bottom water, can I say salinity would be also more? Yes or no? So salinity here increases because of the high density water is found of the bottom area. ठीक है? This is in general diagram for the polar area. This third point, write down. In the polar area, we have learned the third point for the mid latitudes. In the mid latitudes, third point, in the mid latitude, salinity increases with the depth. Salinity increases with depth up to 200 fathoms. What is 1 fathom? 6 feet. So around 1200 feet. Huh? And then it decreases. Then again it decreases. So in the mid latitude, what happens is the salinity will increase up to 200. Then again it will start decreasing. Okay? These are the patterns that we have seen in general. Next is in general, write down. In general, maximum salinity is found in the upper superficial waters. Upper superficial waters. Why? Tell me why. In upper superficial water, why high salinity water is found? Because of insolation is received by the upper surface. So evaporation is controlling here, right? So in general, see here. Can I make the same diagram for salinity also? Somewhat around 35, 36 here. So in general, I'm taking here 35 and here you will come by 33 only. So this is not a major change. However, this change we will write here as halocline. What is halocline? The change in salinity. Okay? The rapid change in salinity. However, this is not as rapid, but in terms of salinity, this can be considered as a rapid change, right? So this is in general diagram. In which areas? This is in general diagram for tropics and subtropic. Polar we have already seen. In the polar area, what was the diagram? This would be the diagram. So somewhat around 32 you can take here. Again, it will reach to 33 in the polar areas. Okay. In general, if you are asked, you can draw this diagram. Otherwise, this question is not gonna be asked in the mains. Why? Because it is clearly written in the optional books also. There is no definite pattern of the salinity distribution. Therefore, question should not be asked from this area. If they are asking, I have given you some of the points. Mention these points and then make this in general diagram. Then so this is about the density, right? Oh, sorry, salinity. So what is the significance of salinity? This question was asked by the UPSC. I have already given you this in your handout. Some of the points artificially they are generated and expanded, okay, so that we can have 10 to 12 points. Just tell me what is the otherwise significance of the salinity? What do you think? How the salinity is important? Why this salinity is important? Circulation of water, very good. Then ships will float. ठीक है, minor thing. ठीक है, ships will otherwise also float. ठीक है, salinity will not impact this navigation much. ठीक है, I'll consider that point also. Then what are the points? Can I say salinity is also important for the marine life? Yes or no? Yes. For example, we have corals, right? So in the upcoming part, we will learn about the corals also. So if I talk about corals, corals will not prefer the fresh water. They need some amount of salinity. So they will prefer fresh water or the saline water? Saline water. And therefore, they will always be away from the river mouths towards the oceans. Why? Because they need salinity. So the salinity is therefore important for the survival of some organisms. Yes, for the biodiversity, salinity is important. Then salinity will decide the density, na? Yes, if the salinity is more, water will be denser. And if the water is denser, it will sink down. Therefore, the circulation of the water is also one aspect that this salinity will decide. Then, what are the other benefit of the salinity? The marine life will be impacted. The marine life, if it is enriched, can I say the income of the farmers, or let's say not farmers, the income of the coastal population will increase? Yes or no? If this harm, jabardasti ke points hai they are. ठीक है? I have created expanded points in this way. Then one more point that you can understand. Now, if I increase the salinity, what will happen to the freezing and warming of that water? क्या होगा? It will be delayed or it will be faster. If I add, let's say, if this is the water in general, and if it is the water in which the saline water I am taking, which water will freeze quickly? Fresh water or the saline? Fresh water, yes. Why? Because this salt particle will take some time. So remember, one more significant, is it there in your handout? Please go by your handout. Is it written there in your salinity? What are the importance? Give me your handout. The points I'm mentioning from here. Number one, it will determine the density. Second, biodiversity. Third, evaporation will be controlled. Therefore, again, water. Then nutrients will be transported with the help of this. Salt is nothing but a kind of nutrient or the mineral, na? ठीक है? Then, ठीक है, छोड़ो. Sea ice formation छोड़ो. Ocean acidity छोड़ दो. These are general heat storage. Now, one more point, just add here, write down here. Saline water freezes slowly. Saline water freezes slowly compared to the fresh water. Compared to the fresh water. write down in the bracket, pure water will freeze at 0 degree C. Will freeze at 0 degree C. Whereas saline water, in bracket 35 ppt, 35 ppt will freeze at minus 1.39 degree C. ठीक है? Right? Done? And same way, melting point will also increase if you are adding the salt. ठीक है? So it will take more time and the evaporation rate is therefore controlled by the salinity, right? Remember this one. So these are the basic points that you can go through. 4-5 points are obviously you are now aware of. Number 1, density will be determined. Number 2, rate of evaporation will be controlled. If the density and evaporation, they are controlled, can I say the oceanic water movement will be controlled? Yes or no? Yes. In this way, these are some basic points. Remember, UPSC has asked this question and therefore I have given you this 10-12 points. In 10 marks they have asked, right? So this is all about density, salinity and temperature. This area is very important. I can't say enough about this area. In the prelims, you can go and check how many questions have been there in the last 10 years, right? Now the next is movement of the water, and in this movement of the water, write down movement of the water. So we will learn this movement of water in 3 ways. One is horizontal, second is vertical, and the third is current. I am writing these currents separately. Why? Because they are the large volume of the water when it is moving. This is also having a definite pattern and the direction. Therefore, the current is separate thing. In case of the horizontal and vertical, the horizontal movement is known as waves. Primarily, this movement is generated due to wind's energy. Tides would be generated primarily due to rather than gravitational, write down tidal pull of sun and moon. And gravitational difference, gravitational force difference at Earth's surfaces. The first that we are starting with, that is tides. Remember, tides are very important. Questions have been asked from this area, and in last 5 years, twice the question was asked from tide itself, right? So tides we are starting with. Now this area will hardly take 15 to 20 minutes. So tide first, let me quickly discuss this tides. Now tell me where the gravitational force is minimum and where it is maximum. On equator, it is minimum or maximum? It is minimum. Therefore, what happens is the water that is now on the equatorial area, this water will be attracted more. Can I say this gravitational difference of the force of the earth is also playing its role? Yes or no? In the polar area, the water will be attracted less towards moon and sun. In case of equator, this would be attracted more. ठीक है? So this is the third factor. What is this third factor? The gravitational difference on the Earth's surface. The force is different on equator and polar area. Now see here, we will include these two factors, one moon and one sun. But first, let me discuss this with the help of alone this moon I am taking here. So for example, moon is also revolving around the Earth, and they all are revolving around the sun. Yes. Now see here, if I consider this is the moon, this is the Earth's surface, and I'm considering the water is equally distributed. Okay, in this diagram, see here, this is the water. Slightly, it is more in the equatorial area this way. This is Earth surrounded by or covered with the water. Now see here, I'm taking this moon factor now. The area which is now under the moon, I'm not considering sun here, the only thing is moon. Now the parts or the points on the Earth's surface or the areas on the Earth's surface which are directly under the moon, can I say the moon's gravitational force or the tidal pull would be experienced more here? Yes or no? Yes. Therefore, what will happen? You will see the water will now recede from this area, and this water will try to accumulate in this manner. Can you understand why? Yes, why? Because moon is pulling this water towards itself, right? In the same way, what happens is when the moon is pulling this water, Earth is also applying the same and equal but opposite direction force towards the back because of its centrifugal force. So what happens is, therefore, water will also increases into some height here also. You will see the bulge will be created in the same manner, right? So can I say there are 4 points if I see here? There are 4 points. One, I'm taking here A, second is B, third is C, and fourth is D. Can I say on point number A and C, the tide is increasing in its height. So this is high tide areas. Yes or no? Yes. So when the water is increasing its height, when the water is coming from the ocean to the land with the height, this is known as high tides. Now in these areas, B and C, the earlier water was here, now the water is receding towards the ocean. Means the water is moving away from the land towards the ocean. Can you see this water is receding now in favor of A and C? Yes or no? Yes. So the 2 low tides and 2 high tides will be created in every 24 hours in each and every parts of the world. Means for example, if you will take Gujarat, coastal area, Gujarat will experience 2 high tides in a day and 2 low tides in a day because of one cycle of the moon. Samajh mein aaya? So what happens is the 2 low tides will be in this area, low tide, second low tide, third, this is high tide, and fourth, this is also high tide. So in every 24 hours, each and every coastal area will see how many high tides? 2 high tides and 2 low tides on daily basis, right? In every 24 hours, ideally, each and every area will be under the same high 2 tides and 2 low tides. Now, the next day, the same story should be repeated, yes or no? Yes. But what happens is, because moon is revolving at a faster speed, so the next day after 24 hours, moon would not be here exactly. Moon would be somewhat in this way. It would be located here. So if you see the point number A, it is here itself. But now this is the area, that is I'm taking here A dash, which is now under the direct impact of moon. So can I say therefore the high tide should occur on A dash rather than A? Yes or no? Yes. So what happens is every 24 hours, it is a delay which is of 52 minutes in total. Okay? Because this gap between A and A dash, this will be covered in 52 minutes by the Earth. So this delay will be caused on daily basis. In total, how much is it is the delay? 24 hours will experience 52 minutes delay. Okay? If I distribute this 52 minutes in 4 parts, can I say here 13, 13, 13 and 13 I can distribute? Yes or no? For example, last day, the waves were, high tide was experienced on A point at 12 p.m. It is afternoon. Na? Next day, it will be experienced at 12, 13 p.m. in this way. So in every 24 hour, there would be a total of 52 minutes delay. Why? Because of this position. Because of the moon is revolving faster. And the same gap will be covered by the earth in 52 minutes. So these areas will come under the same high tide after 30 minutes, 13 minutes. So ideally, can I say there would be gap of, or the tides will Is this clear to everyone? Please make this diagram and write this delay also. This delay I am dividing into 4 parts. 13 minutes here, 13 minutes, 13 minutes, and 13 minutes delay. Okay? So the delay in between two high tides, it would be of 26 minutes in total, 13 plus 13. Delay in total two low tides, the delay would be 13 plus 13 in this way. Okay? Now see here, now I am including the sun also. Yes, this is in general why the tides will occur. समझ में आ रहा है कि नहीं? Yes? Yes. I'll show you this video also. If you have any doubt here in the video, I'll again explain. ठीक है? I'll take 5 minutes more today. ठीक है? Because we are in between our topic. It will take 5 to 10 minutes more. Now see here, we started our class late also. है ना? I was taking some time outside to create this video for you. Now see here, if I take this sun here, the earth is here, the one position is moon is here, the second position is moon is here. Now see here, if sun, moon and earth, they are in line, this condition is known as syzygy. This is syzygy. When they are in line and moon and sun, they both are in the same direction, then it is known as syzygy conjunction, right? So I'm just writing some of the positions. This is your syzygy conjunction. And when they are opposite, means sun is here, earth is there, and then it is the moon, then it is known as syzygy opposition. Syzygy means they are in line. One is when the moon is opposite side, then it is known as syzygy opposition. The one condition when moon is in the same side of the sun, then it is known as conjunction. If the moon is not in this line, rather moon is here, then this position is known as quadrature. And this is quadrature. Right? So syzygy opposition, syzygy conjunction, syzygy opposition, syzygy quadrature, syzygy not syzygy. This is quadrature and this is quadrature. Syzygy, this is the syzygy. Now see here, I'm just isolating these two diagrams in this manner. See here. Let's say this is sun and this is earth and here it is moon. Can I say the moon is pulling water in this side, yes or no? Yes. The force will be applied by earth in the favor of sun side, yes or no? Therefore, in the sun side, you will see the more would be the water attracted here. To balance this counter force of the sun, earth will apply the same amount of force in this side. Therefore, what happens is the normal high tides will increase here in their height. Yes or no? Yes. Even if the sun and moon are in the opposite direction. Why? Because earth is putting the same amount of force in both the sides to balance the force of one, that is this side sun, that side moon. So what happens is in this position, the high tides in general will increase in their height by 20 to 25%. And this condition is known as spring tide. समझ में आया? So normally if it is the 10-meter height of the high tide in some area, on this position, what is this position? Syzygy position, the height of the tide will increase by 20 to 25%. This is known as spring tides. समझ में आया? Now consider they two are in the same side, that is sun, and here it is the moon, and this is earth. Now what will happen? The force will be exercised by this two in the same direction. So what happens is the earth is under the double attack, and the same would be the force this side, which will be applied by the earth to balance this force. So what happens is both the areas will experience, therefore, again, which tide? Spring tide, yes or no? Yes. So even if it is the Syzygy opposition or conjunction, this is opposition, or it is conjunction, the high tides will increase in their height by 20 to 25%, and this is known as spring tide. The question was asked by the UPSC. So this is also your spring tide. So please remember in this diagram, see here, the Syzygy means, Syzygy position means spring tides will be created. Spring tides will be created, and this is your full moon position. Here you can see the full moon, and this is your new moon condition. Can I say on the new moon and full moon, the condition would be the Syzygy positions? Yes or no? Yes. Can I say on the new moon and the full moon, the height of the tide should increase by 20 to 25%? Yes or no? Yes. Therefore, in these two dates, the coastal areas are let's say avoided by the tourists. Okay? The tourists should not go into such areas because of the spring tides. समझ में आया? So on new moon day and the full moon day, can I use this statement? In each and every place on the earth, in a month, 2 spring tides will be formed for sure. Yes or no? In a month, there would be one day that is new moon day. The second day would be the full moon day. On these 2 days, what will happen? The spring tides will be created. Right? We will write this all the things. I'm just explaining here. Now tell me, this is sun, and now here we have earth. Here this is the moon. Can I say the force of sun and moon will be negated by each other? Yes or no? Yes. दोनों ही pull कर रहे हैं. Sun is pulling the water towards it. The moon is pulling the water towards it. Therefore, can I say the force of this attraction will be distributed? Therefore, what will happen? The high tides which are there now, in general, let's say the high tides which occur of 10-meter height, they will reduce in height by 20 to 25% on such days. What are these days? These are quadrature position. If sun and moon at right angles, then high tides will decrease in their height by 20 to 25%, and this type of the tides are known as neap tide. N stands for neap. Neap means niche. Spring. Spring means bouncing of the tides. That is the question which has been asked by the UPSC. So be careful. What are these positions? Syzygy positions will generate which type of the tides? High tides, and they would be spring tide. Quadrature will create neap tide, means the height will reduce. Okay? Just 2 minutes video. Can I play this video? Just if you want to understand this whole tide phenomena, see here now. We'll write about this in the next class. Sound. Do we have sound? कोई नहीं है कैमरा पे? Okay, yes, we have.
Caused by the gravitational attraction of the moon and sun and the
This video was created when I was traveling in a car in the morning itself, when I was arriving in the office. So the background noise that you will hear, that is because of the traffic outside. Okay? So ignore that one, just focus on the tides.
orbits and rotation of the Earth, Moon, and Sun. Gravitational
This sound is of outside air. Okay?
attraction pulls ocean water toward the moon. Because gravitational attraction between two objects.
What is the objective of this diagram? See here, this is new moon here. when sun and moon, they both are in the same side. This is new moon. In our diagram, I created that side. है ना? So remember
It
that one.
moves rapidly with increasing distance. There is more gravitational attraction on the side of Earth facing the moon than
Compared to this one, moon and sun, who is more responsible for the tides? It is the moon because it is near to the earth. Therefore, the more exercise, this pull will be exercised by the moon, right? Now, just I want to show you this video somewhat here.
move into and out of these bulbs. The moon generates large appearances height.
Yes, now see here. This is sun and now we are considering this moon which is revolving around the earth. Now you can see clearly this is the areas on the equator. We have taken polar area here. Okay, earth I am seeing from the upper side. That is pole is here and equatorial areas. You can see the bulge is there in the equatorial areas, right? And it is in the under the direct impact of the moon, right? Now see here.
Tide. When it rotates out of the tidal bulge,
See here how the tidal bulge is also rotating according to the revolution of moon.
The combination of Earth's rotation and the moon's revolution around Earth mean that most coastal areas experience too hot.
What is this position? In which the moon is there and sun is here. It is quadrature. Why? Because sun is pulling the water from this side and the water is now under this moon. It must have been under the high tide now. So what happens is because of the pull of the moon, this high tides will reduce in height because moon is pulling some of the water. Okay? So this is neap tide, which is in general 20 to 25% lesser in height. Then see the another thing.
And two low tides every 24 hours and 50 minutes.
Every 24 hours and 50 minutes. This 52-minute exactly is the delay. She is talking about 50-minute delay. It is exactly 52 minutes.
Tidal range, the height difference between high tide and low tide in the locations of the lunar.
In this, when we say what is the high tide and what is the low tide, the difference in the height of this high and low is known as tidal range. Okay, what is the tidal range of that area? Okay?
And solar tidal bulges also. This produces the moon and sun are
Now see.
their tidal bulges overlap to produce the largest combined tidal bulges. This results in the highest high tides, called spring tides. About 1 week later, at the time of the third quarter moon, the lunar and solar tidal bulges are again 90 degrees apart, and so Earth again experiences neap tides.
I think this is clear now. Okay, how this earth is rotating and how under the impact of moon this tidal bulges are created. The areas in which tidal bulges are created, they are under the high tide. And the areas in which the water is receding, this is nothing but your low tides. If the moon and the sun, they let them come here.
About 1 week later, at the time of the new moon, the lunar and solar tidal bulges again combine to produce spring tides. In all, it takes about 29.5 days to complete this tidal cycle.
This is the condition of new moon. Can I say this is nothing but Syzygy? Now this is Syzygy conjunction or opposition? Tell me, this is Syzygy conjunction. And in this condition, it is new moon. Remember that diagram? Yes, it is new moon. On this 2 days especially, if UPSC will ask the question, this question will be asked in this manner. If the moon, earth and sun, they are in one line, but sun is in the opposite direction to the moon, what would be the high tides created? They would be in higher side or lower side. They are saying in the one line, sun is here, moon is here, in between earth is here. So what would be the impact on the high tides? They are spring tides, yes? The second statement can be framed when they will give you the full moon and new moons. On the full moon, the height of the high tides will increase because of the Syzygy position. Remember that one. It could be Syzygy opposition and conjunction. What is this exactly? On full moon day, Syzygy opposition or conjunction? It is Syzygy opposition. On the conjunction day, it is new moon day. Can you understand now? In the next class, we will understand with this concept perigee and apogee tides. What is perigee? Perihelion and aphelion. Do you remember them? It is based on the distance we have learned in the temperature factor. Go and check that one. Based on the distance, Earth would be closer and farther from the moon, and the tides will be impacted by that distance also. In the next class, we will complete this oceanography and some short, let's say, 2 more topics that are still remain. One is some this landforms, है ना, that I'll show you on the PPT, and one document I'll distribute. The second is climatic patterns. However, we have discussed this equatorial and all these things. Again, I'll just quickly repeat them. ठीक है? By that, then your geography is over. Thank you.